Oh, sorry. I'm so sorry. I wasn't. Okay. I'm so sorry for that. That's that. Okay. Good evening. Happy New Week. Welcome to chemistry class. As we all know, this is chemistry. Happy Monday. Trust your week has been good. Trust your day has been awesome. Trust you've been productive with your day. And so let's start today's class. In today's class, we're considering a new topic entirely, and today's topic is rate of chemical reactions. And so we're considering rates, the laws, the principles, the calculations involving this topic, and then we'll call it a day. Trust it to be a smooth ride. When you hear the word rate, what comes to your mind? Time, right? Time it takes for something to happen, right? That's what comes to your mind when you hear the word rate. And when you hear the word chemical reaction, I'm sure you're not we are not new to that term. It just simply involves substances that undergo chemical change to give rise to another substance. And in chemistry, we know that it is reactant to product, right? Reactant to product. So basically, chemical reaction involves substances undergoing a chemical change in order to give rise to a new substance. And so we are moving from reactant to product. And so we can say A plus B mole of B giving C mole of substance C plus D mole of D. And so basically this is what we mean by chemical reaction. And when you hear it, it just means the time frame, how long it takes something to happen. And so combining together rate of chemical reaction simply says that different chemical reactions have different rates. That means they have different rates and they have different rates. That means it requires different time in order to get to completion. For some reactions, they are very fast. Some chemical change, since we know that chemical reaction involves chemical change, so some chemical change are very fast, like lighting of a matchstick, that would happen within 2 seconds. And some takes a while, that means some are slow. We are considering rusting. We know rusting of iron is a chemical change. Rusting of iron because why it is not reversible. And so rusting of iron for like a example is a slow reaction, but it eventually occur. And some reaction really requires light, or let's say heat, for it to occur. Light might be sunlight, it might be thermal, it might be heat from the Bunsen burner, like heating something on fire. And so some reaction requires heat. You can say some reaction requires light. Example will be your photosynthesis. At night, photosynthesis will not occur because there is no sunlight. And so you can say some reactions are fast, some reactions are slow, and some reactions do not occur in the absence of light. Like chlorination of methane will also not occur. Chlorination of methane will not occur in the absence of light. So that's some of the reaction that requires light. And so, having said this, let's now put this into, let's define it, rate of chemical reaction. It is the number of moles of reactant converted per time. So if you close this to be rates of chemical reaction is the number of moles of reactant converted per time. Moles converted is also the same as product form, right? And so we can say rate of chemical reaction is number of moles of product form per time. So either of the two means the same thing. The number of moles of reactant converted or the product form per time. That means the number of moles of this that will convert to this, right, in an hour or in a minute or in a second, right? Or the number of product moles of product form per unit time. And we know that the SI unit of time is seconds. And so when we are given a question to calculate, we need to first convert it to the SI unit, which is in seconds, and then work with that. The formula for solution, it is the change in concentration per unit time. Change in concentration per unit time. That means change in concentration means the initial concentration and the final concentration. So change will mean delta. That means the final concentration minus the initial concentration. Change is the final concentration minus the initial concentration. That's for reactants, right? And so for product to be the other way around, just basically the change in concentration per unit time. For solid, it is the change in mass. And we know mass, the SI unit of mass is what? Kilogram. And so the change in mass divided by the time taken. And so for gaseous state, it will be the change in volume over the time taken. So we have three depending on the state. If it's in solution, it will be change in concentration over the time taken. If it's for solid, it will be change in mass divided by the time taken. And if it's in gaseous state, it will be change in volume over the time taken. Make sure we calculate in SI units, right? If you are given like an objective question, take a look at, take a look at the units in which the answers have been given, right? And then calculate, thank you, and then calculate in that unit. If not, try to convert it to the SI unit or and then work with the value given. Let's try this calculation question. Marble chips weighing 4.0 gram. From hearing 4.0 gram, what does it correspond with? Concentration, mass, or volume? Definitely mass. And so we'll be working with this formula. Marble chips weighing 4.0 gram were dropped into a large volume of hydrochloric acid, HCl, hydrochloric acid, right? 2.5 gram of the marble remained. 2.5 of the gram marble remained, right? That means that's the final mass, right? After 5 minutes, that's the time taken. Calculate the rate of reaction. From this question, let us draw out the parameters given. First off, we are given initial mass. And our initial mass is 4 gram. We're also given final mass, that's 2.5 gram remained. So that's the final mass. Final mass is equals to 2.5 gram. After 5 minutes, that means the time taken 5 minutes. Calculate the rate of reaction. We'll definitely go with this formula, change in mass. So that's the first thing we need to calculate. And we know change in mass would be the initial year minus the final. Okay, let me write out something. Hold on, calm down. For the product, at time 0, that means at the beginning of the reaction, what would be the mass of the product? 0, right? 0 gram. And this will be regarded as the initial mass, right? Right? Assuming it will take 1 hour, right? And the reactant, you know, the mass of the reactant must be equal to the product, right? The beginning of the reactant must be equal to the final product, assuming it is 100 gram. So at 1 hour, it will be 100 gram. And this is final mass. I made mention of the inverse while I was explaining, but let me take it. This is for the product, right? Let's consider the reactant. At time 0, the mass will be 100 gram, right? 100 gram. And this is what you call the initial mass. At time 1 hour, this will give you 0. Do you agree? Because everything would have been converted to product. and this is final mass. So when I want to calculate change here, this will be final minus initial, right? So this is final minus initial. If I want to calculate change here, what will be initial minus final? Are we good? So we can continue. Thank you. So at this point, it will be the initial mass minus the final mass. And so that would be change equals to 4 minus 2.5, and that is 1.5 gram, right? Okay, so I can clean this up. This was just an illustration. Okay, so rate is change in mass over time, right? Change in mass is 1.5 gram. Our time, we're given in minutes. There's a need to convert to seconds. 60 seconds make 1 minute. 60 seconds is equals to 1 minute. X seconds is equals to 5 minutes. So in order to calculate the number of seconds, you have to multiply, right? And so since 60 seconds is 1 minute, 5 minutes would be 60 times 5. So this is 60 multiplied by 5. And so this is 1.5 divided by 300. One 1.5 divided by 300. That is 0. This is 5 times 10 raised to the power minus 3. Right? And the unit then will be what? The unit of this is in gram. The unit of this is in seconds. And so it will be gram per second. Right? And so it will be gram per second. So let's try another example, and then we can move on to another aspect. Okay. If the concentration of HI increases from 0 to 0.001 mole per dm cube in 50 seconds, what is the rate of reaction? And this is the equation of reaction, by the way. H2 gas plus I gas give 2HI gaseous. If the concentration of HI, right, increases from 0 to 0.001, increases, that's what is in question. She mean decrease from 0, yes, it increases. It increases from 0 to 0.001 mole per dm cube in 50 seconds. What is the rate of reaction? What is the rate of reaction? From the 3 formulas, which should we follow? Definitely that of concentration, right? Because we're giving here that the concentration. And so we'll follow the concentration. And so that solution from here, you would already know that is a solution. Because we're given our values in concentration. The first thing is the initial concentration here is is 0. The final concentration is 0.001 mole per dm cube. So our difference would be what? This minus 0. Anything minus 0 will give you that value. So our difference will be 0.001 mole per dm cube. Right? And our time taking, time taking 50 seconds. Time taking is 50 seconds. Let's calculate rate of reaction. Our rate of reaction definitely would be the change in concentration, which is 0.001 divided by the time taken. We don't need to convert because we're given our time in seconds. So just write 50. The value we get here is our answer, and that should be 0.05. Let me confirm 0.001 divided by 50. That is 2 times 10 raised to power minus 5. 2 times 10 raised to power minus 5. And our value, what will be our unit here? For the concentration, it is mole per dm cube. Time taking, it is seconds. And so when we write it as mole per dm cube per seconds. So it's what we are given that determines the unit that would resolve in. The initial one we did, it was gram per seconds. For volume, which would be measured in either dm cube or cm cube. And so if it is in dm cube, it would be dm cube per seconds. So we cannot say this is the exact unit. It depends on what you are given. If you are given in solution, definitely the concentration will be mole per dm cube and then per seconds. If it is in mass, it will be in gram or kilogram per seconds. If it is in gaseous state, that means you are considering volume, and then it will be dm cube per seconds. So our unit here will be mole per dm cube per seconds. Or you can also write this mole per dm cube per second as mole dm minus 3 seconds minus 1. You mean the same thing. Saying the same thing, either of the two is fine. And so let's move on to another aspect, and that will be factors that affect rate of reaction. Factors that affect rate of reaction. Factors that affect rate of reaction. The first one would be temperature, definitely, right? Because I made mention while explaining that some do not occur except it is applied, and also said sunlight. So presence of sunlight is one of the factors that affect rate of reaction. Presence of sunlight. So just say presence of light. Reaction like chlorination of methane, reactions like photosynthesis require light, and also heat. And so when we want to write it, we say temperature, right? Increase in temperature will bring about increase in rate of reaction. Increase in temperature will bring about increase in rate of reaction. Another factor that can affect is catalyst, right? Catalyst. Catalyst. Are you familiar with the word surface area? Basically means the space, the region of space available, right? And so for this first question, this is the surface area. For this calculator, this is the surface area. So this surface area is definitely smaller than this. And so for solid state, surface area is a factor that affects rate of reaction. And so when the surface area is small, the rate of reaction would occur slower than when the surface area is wide. For two reactions, which is in solid state, and we are considering surface area, reaction of this will be higher. The rate of reaction will be greater than this. Reason being that this has a larger surface area than this. And so surface area. Yes, possible. And pressure is also a factor that affects gaseous states. Pressure, pressure, which will lead to increase in pressure will lead to increase in rate of reaction. So for sunlight, their peculiar